Welcome one. Myself, I am Anbarasan. I am the assistant professor in mathematics, PSN College of Engineering and Technology, Tirunelveli. So today we discuss about functions of several variables. So already we know about the functions. What are the functions? So function has a domain, codomain, and satisfies someone. Okay. So here functions of several variables. Here I will teach about the two topic: maxima and minima of functions of two variables, and another one, a Lagrange method of undetermined multipliers. First one, we will see the maxima and minima of functions of two variables. What is the maximum value? A function f of x comma y is said to have a maximum value at x equal to a, y equal to b if f of a comma b, which is greater than f of a plus h comma b plus k for all small values of h and k. Minimum value, a function f of x comma y is said to have a minimum value at x equal to a, y equal to b if f of a comma b, which is less than f of a plus h comma b plus k for all small value of h and k. So extreme value, what is the meaning of extreme value? It has both maximum and minimum value. A maximum or minimum value of a function is said to be extreme or extreme value of a function f of x comma y. So how to find the function or to find out the value of extreme values is nothing but maximum value and minimum value. So to find the extreme values of a function f of x comma y, so first what are the procedure? So first find dou f by dou x and dou f by dou y. So these are all the topics contains in the partial derivative. So first a function with respect to x, then the derivative of function partial derivative with respect to y. Next step, so we solve the equations. Dou f by dou x equal to 0 and dou f by dou y equal to 0, then only we get the value of x and y. So find r. What is r? Is a second derivative. Dou square f by dou x square and s dou square f by dou x dou y, and chi is equal to dou square f by dou y square. If that is a four condition here, if rt minus s square greater than 0 and r less than 0, then f of x comma y has a maximum value at a comma b. Next, if rt minus s square greater than 0 and r greater than 0, then f of x comma y has a minimum value at a comma b. So first one is r is less than 0 is a maximum value. R is nothing but second derivative. Second derivative is a partial derivative with respect to x. If r is greater than 0 as a minimum value. If rt minus s square less than 0, then f of x comma y has no extreme value. So that means there is no maximum value, there is no minimum value in that function. Okay. At the point a comma b, and the point a comma b is called a saddle point. There is no extreme value, is called saddle point of the function f of x comma y. If rt minus s square equal to 0, this case is not considered for further investigation. So we do not have, or we can't find that function is which one is maximum, which one is minimum, because rt minus s square equal to 0. A function f of x comma y is said to be stationary. When we say that stationary at a comma b, if dou f by dou x equal to 0 at the point a comma b, and dou f by dou y equal to 0 at the point a comma b. Every extreme value is a stationary value. However, the converse need not be true. Every extreme values, maximum value or minimum value is a stationary value, but stationary value is not occur the extreme value. So that is a theorem. The necessary condition for a function f of x comma y to have an extreme at a comma b or so fx of a comma b equal to 0 or fy of a comma b equal to 0. So first derivative with respect to x equal to 0 and first derivative with respect to y equal to 0. Then critical point. A point a comma b is said to be a critical point for a function f of x comma y if fx of a comma b equal to 0 and fy of a comma b equal to 0. So what are the applications in the maxima and the minima of the functions of two variables? That is, so suppose we have a 12 unit square piece of a thin material and we want to make an open box by cutting small squares from the corners of our material and folding the side up. The question is, which cut produce a box of maximum volume? So that only one of them only the application. Second one, that application using the agriculture field. A farmer plans to fence a rectangular pasture adjacent to a river. The pasture must contain 1,80,000 square meter in order to provide enough grass for its. No fencing is needed along the river. So what is the length of the minimum needed fencing material? So these are the two. There is many applications in the many fields, like as banking. For the banking to find the value of the maximum deposit amount or the minimum interest. So we'll see the problem related to the maximum and the minimum. So find the extreme values for x square plus y square plus 6x plus 12. So given function we take, let f of x comma y equal to 0. Let f of x comma y, that is a function is given x square plus y square plus 6x plus 12. So first to find stationary point. So how to find stationary point? So dou f by dou x equal to 0 and dou f by dou y equal to 0. So first to find the derivative. So dou f by dou x, differentiate, partial differentiate with respect to x. What do we get? X square differentiate 2x, y square is constant is 0, 6x differentiate 6, 12 is constant is 0. So what we get the dou f by dou x, 2x plus 6. And dou f by dou y, differentiate with respect to y, differentiate of y with respect to, that is x square is 0, y square derivative 2y and 6x 12, there is no y, so derivative is 0. Next to find r. What is r? Dou square f by dou x square. So dou square f by dou x square. So is the first derivative dou f by dou x, again derivative of this one. So 2, here 2 is constant, x differentiate x is 1 and plus 6 is constant is 0. Next to find s. How to find s? Dou square f by dou x dou y. So from this dou f by dou y equal to 2y. So this function differentiate with respect to x. So here that is no x. So its value is 0. Next chi dou square f by dou y square. So this function differentiate with respect to y. So 2 is constant. Y differentiate y is 1. So 2 into 1 2. Next. So for extremum, dou f by dou x equal to 0. So what is the dou f by dou x? 2x plus 6 equal to 0. And dou f by dou y equal to 0. Dou f by dou y is 2y. 2y equal to 0. What we get? Y is equal to 0. Here 2x plus 6 equal to 0. Plus 6 go to right hand side minus 6. So 2x equal to minus 6. What is the x value? Minus 3. So we get the stationary point. That point is minus 3 comma 0. Okay. Next we have to check that RT minus s square. Okay. So substitute here. Okay. What is the r value? 2. We take the constant is 2. And t value is also 2. Here there is no functions. Suppose the function in terms of x, y in here means we substitute the x value minus 3, y value 0 in here. Here there is all the values are constant. We directly substitute r, t and s values. Okay. So r value here 2 and t value 2. So 2 are 4 minus s square. What is s value? 0. So 0 square is 0. 4 minus 0 we get 4. So 4 is positive, that value is greater than 0. Okay. And what is r value? Is 2 is also greater than 0. So what is our condition? We see that the condition. That condition. So if that is a B, condition of B, if rt minus a square greater than 0 and r greater than 0, then f of x comma y has a minimum value at a comma b. So that is the condition in here. We get rt minus a square equal to 4, which is greater than 0, and r equal to 2 greater than 0. So therefore f of x comma y is a minimum at the point of minus 3 comma 0. Okay, next you find the minimum value. How to find the minimum value? Substitute this value in the given function. Okay, so the minimum value of f of minus 3 comma 0 is given by, so x value we put minus 3 in here, minus 3 square plus y value 0 plus 6 into x value minus 3 then plus 12. Okay, so here what we get, minus 3 square is 9, here minus 18, and here plus 12. Okay, so we get 12 plus here 9, we get 21. 21 minus 18, we get 3. Okay, so that's enough. So that is the minimum value of the function is 3. Let's say the next problem. So same as find the extreme value of f of x comma y. What is the function is given? X power 4 plus y power 4 minus 2x square plus 4xy minus 2y square. Yeah, the same procedure. So f of x comma y is given the function. First to find dou f by dou x, x power 4. So differentiate, partial differentiate with respect to x, 4 x cube, then y power 4 is 0, then minus 2 is constant, x square differentiate 2x, so minus 2 into 2 minus 4x, here 4y is constant, x differentiate x is 1, so 4y into 1, 4y, here there is no x, so differentiate value 0. Here dou f by dou y, differentiate, partial differentiate with respect to y. So first one is 0, there is no y function, y power 4 differentiate 4y cube, and here there is no y, differentiate is 0. Here which one is constant? 4x is constant, so y differentiate y is 1, and minus 2 is constant, y square differentiate 2y, so minus 2 into 2y minus 4y. Next to find r value. Okay, how to find r value? This is the second derivative, second partial derivative with respect to x. So again differentiate of this one, dou f by dou x. So 4 is constant, x cube differentiate 3x square, so 4 3s are 12x square. Here minus 4 is constant, x differentiate x value 1, 4y, there is no x, is 0. Yeah. Then let's find s value. So what is this formula? Dou square f by dou x dou y. Yeah. So this dou f by dou y we differentiate with respect to x. So 4y cube, there is no x, differentiate is 0, 4x, 4 is constant, x differentiate x is 1, so 4 into 1 is 4, minus 4y, there is no x, so differentiate value 0. Next, chi. So dou square f by dou y square. So differentiate this function, dou f by dou y, again partially differentiate with respect to y. So 4 is constant, y cube differentiate 3y square, so 4 3s are 12 y square. Here there is a y square in here, right? Okay. So 4x, there is no y is 0, then minus 4y, minus 4, y differentiate 1 is, y differentiate y is 1, so minus 4. Next to find stationary point. Okay, how to find the stationary point? First derivative equal to 0, that is dou f by dou x equal to 0. So 4x cube minus 4x plus 4y equal to 0, and dou f by dou y equal to 0, 4y cube plus 4x minus 4y equal to 0. Now we take this equation 1 and this equation 2, adding 1 and 2. What do we get adding 1 and 2? That minus 4x plus 4x cancel, plus 4y minus 4y cancel, 4x cube plus 4y cube equal to 0. So take the common value of 4 and cross multiply, 0 by 4 is 0, and x cube plus y cube equal to 0. So this is a form of a cube plus b cube. So what is the formula of a cube plus b cube? A plus b, a square plus ab plus b square. So x plus y, x square plus xy plus y equal to 0. In function, two functions, I can say this is sum x, this is sum of y. So sum x dot y equal to 0. So either x value 0 or y value 0. Right? Okay. So either x plus y equal to 0. What we get? X equal to minus y. Then x square plus xy plus y square equal to 0. Then that value in here. First we take x equal to minus y. Okay. Substitute x equal to minus y in the equation of 2. So what is the equation 2 in here? Substitute the x values minus of y. Okay. So what we get? 4y cube minus 8y equal to 0. Already minus 4y in here. So minus 4y minus 4y minus 8y equal to 0. So y cube, take the common value of 4. What is the remaining? Y cube minus 2y equal to 0. And consider these two terms. Take the common value of y. So remaining y square minus 2 equal to 0. So either y equal to 0 or y square minus 2 equal to 0. So y square equal to 2. What is the y value? Plus or minus root of 2. So we get the y values. Next, to find the x value. So substituting y equal to 0 and plus or minus root of 2 in x equal to minus y. If y value 0 in here, what is the x value? Is also 0. Suppose y value plus root of 2, then x value minus root of 2. Suppose y value minus root of 2, then x value plus root of 2. So hence the steady points are, we get the pair of points 0, 0, minus root 2, root of 2 and root of 2, minus root 2. Next to find at the points what are the question. So at minus root 2, root 2, rt minus t square. So see the previous one, rt minus t square, what we get? Here we have what rt minus s square, right? So r into t, what is r value? 12x square minus 4 and t value 12y minus 4. So multiply these two one and minus of s square. Okay. So after we substitute x value minus root of 2 and y value root of 2. So we get the answer 384, which is greater than 0. So what is the r value? Here 12x square minus 4. Okay. So if substitute the x value minus root of 2, this minus root of 2 in here, what do we get? Is the square value is always positive. Okay. So 24 minus 4, what do we get the value? 20, which is also greater than 0. Suppose we take the point root 2, minus root 2. So we get the same answer, rt minus s square equal to 384, which is greater than 0 and r is greater than 0. So these 2 points have the minimum value, right? Yes. So at 0, 0, rt minus s square equal to 0. So we do not see any result about this rt minus s square equal to 0. So at minus root 2, root 2 and root 2, minus root 2, the function f of x, y has a minimum value. Okay. Then substitute these x value minus root of 2 and y value root of 2 in the given function here. You substitute, okay, minus root of 2 power 4 and plus root of 2 power 4 minus 2 into minus root of 2 the whole square plus 4 into minus root of 2 plus root of 2 minus 2 into root of 2 the whole square. Okay. So what we get the answer? Answer is 8. After we simplify, we get the answer. The minimum value is 8. Okay. So these are the problem. Find the maximum and minimum of x cube y square 1 minus x minus y. This is the next problem. Okay. So let's, what is the given function f of x, y? X cube y square 1 minus x minus y. So dou f by dou x, partial differentiate with respect to x. So here we have to use u dot v formula, the product rule, right? So u dot v, uv dash plus vu dash. So what is the d by dx of uv dash plus vu dash. So we consider this is a constant and differentiate of this one with respect to x cube differentiate 3x square into y square plus, now this is constant, differentiate this one with respect to x. So this one is constant, differentiate 0, minus x differentiate minus 1 and minus y is 0. Okay. So that value is equal to what we get. So here that plus into minus x cube y square. Next to find dou f by dou y. Okay. Same u dot v. So here u dot v means, yes. So these are constant 1 minus x minus y and differentiate y, right? So x cube is constant, y square differentiates 2y, then plus x cube y square is constant and differentiate this one is constant, minus x is 0, minus y derivative is minus 1. So we get 2x cube y, 1 minus x minus y, then plus into minus x cube y square. Next to find r value. This is r dou square f by dou x square. Right? So differentiate this one again, the partial differentiate with respect to x. So now this is constant and 3 is constant, x square differentiate 2x, so 3 2s are 6x y square plus, now this one is constant, so differentiate this one with respect to x, 1 is 0, minus x differentiate minus 1 and minus y is 0. And here minus y square is constant, x cube differentiate 3x square. So simplify this one, here plus into minus minus, the same terms, what we get? So minus 6x square y square. So next you find the t value. So how to find t value? Dou square of by dou y square. Okay. So this one, so differentiate, again differentiate, partial differentiate with respect to y. So same u dot b formula. So this is constant, differentiate this one, 2x cube, y differentiate y1, and this one is constant, differentiate this one, 1 minus x, that is 1 is 0, minus x is 0, then minus y is minus 1. The last term, minus x cube, y square differentiate 2y, right? Okay. So here what we get? Plus into minus minus, 2x cube y, here also minus 2x cube y, so addition of this one, minus 4x cube y. Next find s value. Yes, what is this? Dou square of by dou x dou y. So differentiate this one with respect to x. Okay. So this is a constant value. Differentiate this one, 6x square y. Right? Okay. Then plus this is constant. Differentiate this one with respect to x. 1 is 0, minus y is 0, and minus x differentiate minus 1. And this one differentiate with respect to x. So minus y square, x cube differentiate 3x square. Okay. So simplify this one. So plus into minus minus 2x cube y, here minus 3x square y square. So let's find the stationary point. How to find the stationary point? So first derivative equal to 0. So dou f by dou x equal to 0. What is the dou f by dou x? 1 minus x minus y into 3x square y square minus x cube y square equal to 0. So consider these two terms. Take the common value, x square y square. What is the remaining? 1 minus x minus y. Here the remaining is 3, and here the remaining is x equal to 0. So either that value is equal to 0 means that x square y square equal to 0 means x value 0 and y value 0. So we do not have any result. So we consider this one. So 1 minus x minus y of 3. Multiply 3 minus 3x minus 3y, then minus x equal to 0. Okay. So minus 3x minus x, what do we get? Minus 4x. So minus 4x minus 3y equal to that plus 3 go to right hand side, minus 3. So throughout multiply the minus 4x plus 3y equal to 3. Okay. Next dou f by dou y equal to 0. Okay. So these are dou f by dou y. Okay. So consider these two terms, take the common value, x cube y, what is the remaining? 2 times of 1 minus x minus y minus y equal to 0. So multiply the 2 minus 2x minus 2y minus y equal to 0. So minus 2x minus 2y minus y minus 3y plus 2 go to right hand side, minus of 2. Throughout multiply minus, so 2x plus 3y equal to, we consider this a second equation. So previous one, that is dou f by dou x. Dou f by dou x equal to, so that dou f by dou x equal to 0, that 4x plus 3y equal to 3, that is the first equation. Second equation, 2x plus 3y equal to 2. So solving these equation 1 and 2, we get the x value 1 by 2 and y value 1 by 3. So substituting this pair of points 1 by 2 to 1 by 3 in R and S and T. So substitute in here R. Okay. So x value and y value, T, S. So what we get? R value minus 1 by 9, S value minus 1 by 12, T is equal to minus 1 by 8. After that we have to find RT minus S square. So multiplication of R and T, so that minus and minus plus 1 by 9 into 1 by 8, 1 by 72. Then minus S square, differentiate this one, square of this one, minus 1 by 12 the whole square, 1 by 144. We take the LCM, then subtract this one, what we get? That value is greater than 0. And what is R value? Minus 1 by 9, which is less than 0. Okay. So therefore, f of x is maximum at 1 by 2, 1 by 3. Which find maximum value? How to find the maximum value? So substitute x value 1 by 2, y equal to 1 by 3 in the given function, this one. Okay. So what we get the value? 1 by 432. Next. So next one, see Lagrange's method of undetermined multipliers. So let f of x comma y comma z be a function of 3 variables subject to the constraint pi of x comma y comma z equal to 0. The stationary values of f of x comma y comma z for the values of x comma y comma z are given by the equations dou f by dou x plus lambda times of dou pi by dou x equal to 0. So next, dou f by dou y plus lambda times of dou pi by dou y equal to 0. Consider the third equation. And dou f by dou z plus lambda times of dou pi by dou z equal to 0. After that, solving the equation 1, 2, 3, 4, we get the values of x, y, z and lambda. So which esteems the function f of x comma y comma z values. So in this case, lambda is an unknown multiplier and is known as Lagrange multiplier. The lambda is called the Lagrange multiplier. Okay. So to find the values of x, y, z, x comma y comma z, for which f of x comma y comma z can have a conditional extremum, and then construct the auxiliary function capital F of x comma y comma z is given by. So how to write capital F of x comma y comma z equal to small f of x comma y comma z plus lambda times of g of x comma y comma z. So next we have to find dou f by dou x, partial differential f with respect to x, partial differential with respect to y, partial differential with respect to z, then partial differential with respect to lambda, then equate to 0. All the values equal to 0. So from this we get the values for x, y and z. So we have to see the one problem based on Lagrange method of multiplier. A rectangular box which is open at the top is to have a volume of 32 centimeter cube. Find the dimension of the box that requires the least material for its construction. So what is given? Rectangular box is given. The volume of the box is given. So to find the dimension of the box. What are the meaning of dimensions? So rectangular box is considered as a cuboid. So it has the length, breadth and height. It is a 3-dimension. Okay. So to find the dimension of the box that requires the least material for its construction. Okay. So let's x comma y comma z be the length, breadth and height of the box respectively. If the surface area of the box is least is given in the problem, then the materials for the construction will be the least. So to minimize, okay, so capital S equal to xy plus 2 times of yz plus 2 times of zx. So how to write this equation? Okay, so it is a open box. It is open box, open at the top. Okay, so open at the top means there is no height. Okay, that it contains in the top level there is no height. In the top level there is only the length and the breadth. Okay, so that is the length in the breadth is xy. Okay, plus and 2 times of remaining that 2 faces yz plus yz is a 2yz, and remaining the 2 faces zx plus zx 2zx. So open at the top means it has only the 5 faces. Okay, so subject to the condition that volume of the box is given x, y, z equal to 32. What is the x, y, z? Is a volume. This is a formula for volume of the cuboid, length into breadth into height. This value is equal to 32. So consider. So this is a function we consider is f. F is equal to xy plus 2yz plus 2zx, and pi is a function xyz minus 32. The auxiliary function is given by g equal to f plus lambda pi. Next to find the stationary point of g. So dou g by dou x equal to 0, dou g by dou y equal to 0, and dou g by dou z equal to 0, dou g by dou lambda equal to 0. Okay. So what is the g function? That is g function is f plus lambda pi. So this is f function plus lambda times of pi function xyz minus 32. Okay. So to find dou g by dou x, partial differentiate g with respect to x. Here xy, y is constant, x differentiate x is 1, and 2yz, there is no x is 0. Here 2z is constant, x differentiate x is 1, and here multiplication of here. So lambda yz is constant, x differentiate value 1. That value is equal to 0. So similarly, dou g by dou y, x plus 2z plus lambda x is equal to 0, and dou g by dou z 2x plus 2y plus lambda xy equal to 0, and dou g by dou lambda, okay, partial differentiate with respect to lambda. Here there is no lambda, this one will be 0, and lambda times of this one. So So x, y, z minus 32 equal to 0. Now consider the equation 1, 2, 3 and 4. So first equation is divided by y, z. That implies what we get? So 1 by z plus 2 by y equal to that plus lambda go to right hand side minus lambda. Okay. Second equation divided by x is z. So 1 by z plus 2 by x, that plus lambda go to right hand side minus lambda. Third equation is divided by xy. So that implies 2 by x plus 2 by z equal to minus lambda. So solving these three equations. So all the three equations are minus lambda. Both of the right hand side is equal. So we equating the LHS left hand side. We get the answer of x value minus 4 by lambda, y value minus 4 by lambda and z value minus 2 by lambda. So using these values in equation 4. So substitute the x value, y value, z value. Okay. So minus 1 by 4 lambda into minus 1 by 4 lambda into minus 2 by lambda. What do we get? So 4 into 4 16, 32, 16 into 32. Okay. So minus 32 by lambda minus 32 equal to 0. That minus 32 go right hand side plus 32. What we get the lambda value? Minus 32 by 32 is minus 1. Is the only possible value. So substitute the x value, that is a lambda value minus 1 in here. What we get? X value 4, y value 4, z value. So thus the dimensions of the box are x comma y comma z. X value is 4, so 4 centimeter. Y value is 4 centimeter, and z value 2 centimeter. Okay. We see the next another one problem. So find the volume of the greatest rectangular parallel pipe which can be inscribed in the ellipsoid. The equation is given x square by a square, x square by a square plus y square by b square plus z square by c square equal to 1. So let the vertex of rectangular parallel pipe to be x comma y comma z. Then the edges of the parallel pipe to be 2x, 2y, 2z. That is the length. So volume is a formula, length into breadth into height. So 2x into 2y into 2z. So 8 into xy z. So here the problem, volume of the rectangular parallel pipe. So is a 3 dimension and the 6 faces in here. Okay. So that is the reason for 2x, 2y, 2z. 2 length in here, 2 breadth and 2 heights. Okay. So multiplication of these 2 2s are 4, 4 2s are 8. So 8 xy is equal to f. We have to maximize the problem. Maximize, that is the greatest. We take maximize b subject to the condition pi is equal to x square by a square plus y square by b square plus z square by c square. So these plus 1 go to left hand side, minus 1 equal to 0. Okay. Next write the auxiliary equation, that is the auxiliary function. F is given by capital F equal to small f plus lambda pi. So capital F equal to what is the small f? 8 xyz plus lambda times of what is the pi value? X square by a square plus y square by b square plus z square by c square minus 1. Okay. Next to find the stationary point. So dou f by dou x equal to 0. So differentiate this one with respect to x. Here 8yz constant, x differentiate x is 1 and plus multiplying here lambda is constant, x square differentiate 2x. Other remaining functions there is no x, differentiate is 0. So 2x lambda by a square equal to 0. So similarly differentiate partially with respect to y, dou f by dou y equal to 0, we get 8xz plus 2y lambda by b square equal to 0. And dou f by dou lambda dou z equal to 0. So 8xy plus 2z lambda by c square equal to 0. Okay. Next. So from the above equations we get lambda value. So from this one to find the lambda value, go the remaining the terms go to the right hand side. What do you get? Minus 4a square y z by x and minus 4b square x z by y and minus 4c square x y by z. Yeah. So all the lambda values are equal and cancelling the common values minus 4. Okay. So what is the remaining? A square x y z by, and here the next step multiply x and divide by x, and here multiply y divide by y, and multiply z divide by z. So what do we get? X square, a square x y z by x square, b square x y z by y square, c square x y z by z square. So dividing by x y z and rewriting we get, okay, through divided by x y z. So x square by a square by 1 plus y square by b square by 1 equal to z square by c square by 1 equal to, okay, x. So additional take the LCM of this one, a square plus b square plus c square by, what we get, 1 plus 1 plus 1, we get 3. So already we know this value is equal to 1 in the given problem. So this value equal to 1 divided by 3. So therefore x square, this is x square equal to a square by 3. So consider these two terms, right? This first term and in this term. So x square by a square equal to 1 by 3. So cross multiply a square, x square equal to a square by 3. So x equal to a by root 3. Okay, same as y square equal to cross multiply b square by 3, y is equal to b by root 3. And z square, cross multiply this c square. So c square by 3, what is z value? C by 3. So the extreme point is a by root 3, comma b by root 3, comma c by root 3. So the maximum value of v equal to 8 x y z at the extreme point. So substitute the x value a by root 3, y value b by root 3 and z value c by root 3 in here. What do we get? The multiplication a b c, the denominator root of 3 into root of 3 is 3. So 3 root 3. So we get the answer 8 a b c by 3 root 3. So these are the some problems you can try. Find out the minimum value of x square plus y square subject to the condition ax plus by equal to c, and show that the rectangular solid of maximum volume that can be inscribed in a sphere is a cube, and find the dimension of the rectangular box without a top of maximum capacity whose surface is 108 square centimeter. Find the point on the surface z square equal to xy plus 1 nearest to the origin, and find the stationary values of u equal to x plus y plus z subject to the condition a by x plus b by y plus c by z equal to